In this video, we're going to work on complex numbers. We're going to try and convert them from the Cartesian coordinates to polar coordinates. So firstly, the general form for some complex z in the Cartesian coordinates is x plus iy, where x is the real part and y is the imaginary part. And we want to convert it onto the polar coordinates to have it in the form z equals r e to the I theta. Now we need to know what r and theta are. So r is the distance from the origin and theta is the angle between the positive real axis and z, or the line connecting z and the origin. So we're going to draw it first. We're going to have this coordinate system where that is our imaginary axis, and then we have our real axis. Okay, now we're going to have some z's. Say z equals minus 2 plus 2i. So we have minus 1, minus 2 on the real axis, and then plus 1, plus 2 on the imaginary axis. And that leaves us with z being here. Now, as we said earlier, r is the distance between the origin and our z, which can also be written as the absolute value of z. And then theta is this angle between the real axis and our z. So this is our theta. Now if you look at this picture, you can see that this is a right-angled triangle with the shorter sides being x and y. So therefore, using Pythagoras, we have that r squared equals x squared plus y squared. And if we take a square root of that, we have r being the square root of x squared plus y squared. Now we want to find theta. I'm going to circle that up. Okay. Now again, if we look at the picture, and we'll try to draw a unit circle there. Okay, this is our unit circle with the radius of 1. And then by definition of sine and cosine, we have that the vertical axis, so this part, is sine of theta, and the horizontal part is the cosine of theta. But this is for the radius of the length 1, and now we need the radius r. So if we just simply multiply r times this cosine theta, that will give us this whole length up to the -2. This is -2, and that is just x. And we can do the same for sine. So we have r times sine theta. That gives us this whole length up to here, and that is 2. And this is our y. So having that, we can guess our theta from it now. So we have r times cosine theta equals x, and therefore cosine theta is x over r. And then we're going to do the same for y. So r times sine theta is y, and therefore sine theta is y over r. Now, if we think of a tangent, that is a trigonometric function that uses both cosine and sine, and it is just, so tangent theta is sine theta over cosine theta. So tangent theta is just equal to, we're going to do it this way, it's y over r over x over r, which is just y over x. And then if we take the inverse trigonometric function, we have tangent to the -1 of y over x equals theta. Now, y over x in our example is, y was -2, x is 2, which is just -1. So if you take the calculator and if you look at that, then you get the result of tangent to the -1 of -1 is -pi/4. But if you have a look at the picture, -pi/4 is this angle. But we need the angle to be on this side, so we need to just add pi to it. Therefore, -pi/4 plus pi is simply 3/4 pi, and that is our theta. So we have our r, which was where was it? It's just x squared plus y squared. We're going to calculate it again. X squared is -2 squared plus y squared is 2 squared, and that is 2 square root of 2. And then theta is 3/4 pi. And therefore z, which was -2 plus 2i, is now r, which is 2 square root of 2, times e to the I theta, which is 3/4 pi. And that can be also written as 2 square root of 2 cosine theta, which is 3/4 pi, plus I sine theta. Thank you.